Hello friends, this is Shravan. This is my YouTube channel Civil Engineering Tutorial by Shravan. To subscribe my channel, click on subscribe button and click on bell icon for more interesting updates. In this video lecture, I will explain you retrofitting of G+3 building by using ETABS software. Generally, retrofitting is the process which is used to decrease the deflection value, shear value as well as bending moment value for the respective building. In this tutorial, I will model the two structures. One is without using retrofitting and another structure is with using retrofitting process. Go to ETABS software, click on ETABS software. Just cancel this. So initially we need to select the units. Just I am selecting the units as kilonewton meter. So after that, click on file, click on new model. So here we need to select the no option. So here we need to give the grid dimensions data as well as story dimensions data for this respective building. For this respective building, just I am assuming number of lines along x direction are 4, number of lines along y direction are 4, spacing in x direction is 3, again spacing in y direction is 3. So just we need to enter the number of stories. Here I am assuming G+3 story building, nothing but 4 slab. Each slab will be consisting of 3 meters. So we need to assume the typical story height as well as bottom story height. So after that, click on grid only, click on OK button. The model will be open like this. Left hand section window will be consisting of plan view of the respective G+3 building. Right hand section will be consisting of 3D view of the respective building. So after grid lines is open like this. So after this grid lines, so we need to select the IS code. So for that, click on options, click on preference. So here we need to select the steel frame design. So initially we need to change the steel design. So here I am changing the steel design from AISC to IS code. Just click on letter I. So after that, select IS 800 1998 code, click on OK. So after that, click on options again, click on preference again, click on concrete frame design. So here we need to select the Indian code. So here I am changing ASI code to Indian code IS 456 2000, click on OK. So after this process is done, we need to give the grade of concrete, grade of steel for this respective G+3 building. So for that, go to define option, click on material properties. So here we need to click on add new material. Just give the material name here. Just I am assuming M30 grade concrete. So here we need to give the design property data as per IS 456 2000. Here I am assuming compressive strength will be consisting of 30,000. So after that, we need to assume the yield strength. Just I am taking the yield strength is 600,000. So after that, we need to enter the yield stress value also. Just I am taking 600,000 yield stress value. Click on OK. So after that, click on OK button again. So after defining the material properties, just we need to define the beam size, column size for this respective G+3 general building. So for that, go to click on define option, click on frame sections option. So here we need to delete all previous section initially. So for that, select all your previous section. Just I'm selecting all my previous section, click on delete property. So after that, here we need to click on add rectangular section. Here we need to give the section name. Just I'm assuming the section name will be consisting of 0.3 cross 0.4 beam size. So after that, we need to select the material property data here. Just I'm changing the material from steel to M30 grade. So here we need to give the depth as well as width of the respective beam. Just I'm assuming width of the beam is 0.3 and depth of the beam is 0.4. So click on reinforcement. So here I am selecting the reinforcement for this respective beam. So here we need to select the design type is beam section. So click on OK. So after that, click on OK button. So after defining the beam section, just we need to delete this W44 by 335. So further select W44 by 335, click on delete property. So after adding the beam section, just we need to add the column section. So further click on add rectangular option. So here I am selecting the column section. Just I am assuming column section will be consisting of 0.4 cross 0.4 is my column size. So after that, just we need to give the material type. So just I am changing the material type to M30 grade. So here we need to give the value of depth as 0.4, again width as 0.4. Click on reinforcement. So after that, select your column section here. Just we need to assume the bar size as well as corner bar size. Just I am taking the bar size will be consisting of 16D as well as corner bar size is also same dimension. Just I am taking it as 16D also. Click on reinforcement to be checked. Click on OK. So after that, click on OK button. So after that, click on OK. So after defining the beam size, column size, just we need to define the slab thickness for this respective building. So for that, go to define option, click on wall slab deck section initially. Here we need to delete all deck 1, plank 1, slab 1, wall 1. So after that select your slab, add new slab. Just we need to give the slab. Just I am assuming slab thickness will be consisting of 125 mm. So here we need to select the material as M30 grade. Just I am taking the membrane thickness as 0.125 as well as 0.125 is for the thickness for the respective bending. Click on membrane option, click on OK. So after defining the slab thickness, just we need to delete wall 1, click on delete section, click on OK. So after defining the beam size, column size as well as slab thickness, just we need to assign the respective properties for the respective G+3 building. So for that initially just I am selecting create lines in region. So initially we need to select all stories. So after that select the beam section. So just drag to the respective plan view. So it will assign the respective beam sections like this. So after assigning the beam section, just we need to select the column, nothing but I section. Just I am selecting the column property here, 0.4 by 0.4. Just drag to the respective whole structure. So it will assign the column sections like this. So after assigning the respected column, just we need to assign the slab thickness. For that you need to select the create areas. So here we need to select the property as S125. Just drag to a respective plan. So it will assign the slab like this. So after that we need to click on this right mark. So here we need to select the object fill, apply to all windows, click on OK. So it will assign the slab like this. So after assigning the slab, we need to delete the beams, columns as well as slab at the ground story. So for that go to select option by story level. Here we need to select the base, click on OK. So click on delete button. So after assigning the beam size, column size as well as slab thickness for this respective building, just we need to define the load cases. So for that go to define option. We need to click on static load cases. Just here I was assuming dead load as well as live load. Along with this load cases, just we need to assume earthquake load in X direction. So here we need to select the type as quick. Just we need to pick IS code. Just I'm taking IS 1893 2002 code. Click on add new load. So after that we need to select the earthquake load in Y direction. Click on add button. So after defining the respective earthquake load in X direction, earthquake load in Y direction, we need to modify this respective two load cases. So for that initially select earthquake load in X direction, click on modify lateral load. So here we need to select the seismic zone factor. Just I am assuming seismic zone will be consisting of zone 5, which is consisting of Z equals to 0.36. So after that we need to select in X direction, click on OK. So after that select EQY, click on modify lateral load, click in Y direction. So here we need to select 0.36, click on OK. So after that click on OK button. So after defining the load cases, just we need to assign to the respective building. So for that initially we need to assign the dead load, nothing but the self weight of the structure, dead load of the beam, dead load of the column as well as dead load of the slab. So for that initially we need to select all the structure by using Ctrl A button. Go to assign, click on joint point loads. Here we need to select the force. So add to existing loads. Just we need to enter the value of load here. Just I am taking value of load as 1111. Click on OK button. So it will assign the self weight of the structure like this. So after that we need to calculate the beam dead load. So for that initially we need to select the beams. For that go to select option, frame sections option, select 0.3 by 0.4, nothing but the beam. Go to select. So go to calculator. So here we need to calculate the dead load of the beam. So for that initially we need to take the dimensions of the respective beam, 0.3 by 0.3. We need to multiply these respective dimensions with unit weight of the concrete. Just I am taking 25. Click on enter button. So it will consisting of 3 kilonewton per meter. So for that go to assign option. So here we need to select the frame line load. Here we need to select the distributed load. So here we need to enter the uniform load, which is consisting of 3. So here we need to select, click on OK in gravity direction. So after that we need to assign the dead load of the column. For that go to select option. So here we need to select the frame section. Just select 0.4 by 0.4, nothing but the column. So after that we need to calculate the column dead load also in the same way. Just I am selecting 0.4 by 0.4 is the column size. We need to multiply this respective column size by unit weight of the concrete. So it will give the value of 4. So for that go to assign option again, frame lines load again, distributed load again. Here we need to enter the value as 4 again. So here we need to take the add to existing load cases, gravity Y direction, click on OK. So after that we need to calculate the dead load of the slab. So for that initially we need to take the slab thickness. So we need to multiply this respective slab thickness with the unit weight of the concrete. So it will give the value of 3.125, which is the dead load for the respective slab. For that go to select option, go to select wall slab deck section, select S125, click on OK. So after that go to assign option, shell area load. shell area loads. So here we need to select the uniform load, add to existing load. So here we need to select 3.125. So add to existing load, click on OK. So after that we need to assign the live load for this respective building. So for that, go to select option again, wall slab deck section again, select S125 again, go to assign option again, shell area load again, uniform load again. Here we need to change the load case name from dead load to live load. Just I'm taking the live load value as 3, add to existing load option, click on OK. So after assigning the live load for this respective building, just we need to assign the earthquake load in X direction as well as earthquake load in Y direction. So for that, select all the structure by using Ctrl A button, go to assign option, shell area load here, uniform load here. Just we need to select earthquake load in X direction, add to existing load. Just we need to take the value of intensity as 50% of the live load, which is 1.5 in gravity Y direction, click on OK. So after that we need to select all the building again, go to assign option again, go to shell area load again, uniform load again. You need to change the respective load case to earthquake Y, add to existing load in global Y direction, click on OK. So after that we need to assign the support for this respective building. So for that, go to select option, story level, select the base, click on OK, go to assign joint point. Here we need to select the restraints, nothing but the supports, select the fixed support, click on OK. So it will assign the fixed support at the base. So after that we need to assign the diaphragm. Diaphragm is nothing but the center point of the respective building. Go to assign option, joint point load, diaphragm, select D1, click on OK. So it will assign the diaphragm like this. So after that, go to select your right mark here. So diaphragm extend, apply to all windows, click on OK. So it will assign the respective diaphragm for the respective 3D view also. So after assigning the respective load cases, we need to analyze the respective structure. So further, go to analyze option, click on set analysis option. Here we need to select the parameters. Just I'm taking the parameters as 12, click on OK, click on OK. Again go to analyze option, check model. So here we need to check the errors for the respective building. Just I'm checking this 3 line checks, click on OK. So here my model is observed with 0 error, 0 warning. So after that, go to analyze option, click on run analysis. So here we need to save the respective model building. Just I'm taking respective desktop. So here we need to select the folder retrofitting process. I'm selecting new folder. Just I'm giving the name as general building GB, select enter. So after that we need to give the file name. Just I'm taking GB G+3 building. So click on OK. After analysis part is completed, so right side 3D view will be consisting of respective deflection values. So this is the deflection of the respective building due to presence of the dead load case. So here we need to see the output file, nothing but the deflection value, shear value as well as bending value for this respective G+3 building without using any retrofitting, nothing but the general building. So for that, go to display option. So here we need to select the show tables. So initially I'm selecting the load cases. Just I'm selecting load case earthquake load in X direction, static load cases, click on OK. So after that, select displacement value, select story drift. So after that, select building output value, select the place mark, again select story shear, select click on OK button. So after that, it will create the deflection value in X direction as well as Y direction. Initially I will save this deflection value in Excel sheet. Just Ctrl C button. So after that, select Excel sheet and I will save this respective results in Excel sheet initially. So I am saving this respective results in Excel sheet. So it will be consisting of earthquake load in X direction deflection value. So after that, select sheet 2. So after that, select your respective shear values. Just I am selecting all the shear values, select Ctrl C button. So after that, select paste here in Excel sheet. So this is the results which are related to the general building. So it will be consisting of deflection value as well as shear value in X direction as well as Y direction, movement value in X direction as well as Y direction. So just we need to compare this respective shear values as well as deflection values with using retrofitting. Now I will explain you retrofitting of G+3 building. So for that, initially I will save this respective model. Just cancel this. So click on save as button. So after that, we need to go to respective retrofitting. So in this retrofitting, we need to pick .edb file of G+3. Just I'm copying this respective building. So initially I will create new folder. Just I will name it as retrofitting, retro. So just save it. Just I'm saving this respective .edb file in this respective retrofitting folder. So after that we need to open this respective G+3 building with retrofitting. So it will directly open this respective G+3 building, general building. So in this general building, just we need to unlock this respective model initially. So after unlock process is done, we need to delete all the columns. So for that, go to select option. Here I am selecting frame sections, select column 0.4 by 0.4, click on OK. So delete option. For this respect to retrofitting building, just I am changing my column size from 0.4 to 0.5. So for that, initially we need to go to define option. So go to frame sections option. Here we need to add section designer, nothing but SD section. Click on add SD section. So here we need to select the section name. Just I am taking a section name as retrofitting RET. So after that, click on concrete column, click on section designer. So here we need to add the rectangular portion for this respective section designer portion. So initially I will add the old column for this respective building. So for that, click on drawing. So here we need to select the solid shape rectangular portion. Just we will initially add solid shape, so which is consisting of some dimensions. I will show you this respective dimension. So it will be consisting of 0.5 by 0.5. So initially I will change the respective 0.5 to 0.4. Just I am changing this respective width as well as height 0.4. So after that, click on OK button. So it will change the respective dimensions from the respected 0.5 to 0.4. So after that, we need to select the reinforcing here. So it was selected it as no option, so we need to select it as S. So after that, click on OK. So after selecting this respective reinforcing bars, just we need to click on here. So after that, we need to give the reinforcing bar size. So here, as per my assumption, just I am assuming bar size will be consisting of 16D for all the sections. So apply to all edges, click on OK. So after that, we need to add the one more column which is consisting of 0.5 by 0.5, nothing but the cover for this respective 0.4 by 0.4 section. So for this respective retrofitting section, so for that, go to draw option, go to draw solid shape rectangular. So here we need to pick center point. So here I was added the center point for this respective outer rectangular portion. So now I will show you the respective outer rectangular portion dimension. So for that, initially we need to click on rubber band zoom button. This time selecting rubber band zoom option for this respective column. So after that, select outer rectangular portion, just click on it. So it will be consisting of 0.5 by 0.5 outer rectangular cover. So after that, we need to select the again rectangular cover will be consisting of reinforcing. Click on S button, click on OK. So after that, select reinforcement bar, again select this respective reinforcement. So here I am selecting respective reinforcement also consisting of 16D again. So here we need to select 16D again, click on apply to all edges, click on OK. So it will assign the respective cover like this. So after that, here we need to click on cancel button. So after that, open your respective ETABS software. So it will be consisting of section designer of respective 0.4 by 0.5 original column. So after that, we need to increase the respective column size to 0.5. So this is the outer column will be consisting of 0.5 by 0.5. So this is the addition of respective extra reinforcement for the respective 0.4 by 0.4 column. So after that, click on cancel. So after that, click on OK button. So here I am added the respective rectangular section. So nothing but retrofitting. So after that, select a column 0.4 by 0.4, click on delete property, click on OK. So after defining the retrofitting structure, just we need to assign to the respective structure. So for that, initially we need to change the one story to all stories. So after that, select I section. So here we need to select the rectangular section of retrofitting column, assigned to the all building by using top view of the respective building. So after that, we need to assign the load cases for this retrofitting building. So for that, initially go to define option, go to static load cases. So it will be consisting of dead load, live load, as well as earthquake load, as well as earthquake load in y direction. Just we need to apply the earthquake dead load for the respective column. Why? Because I was applied dead load of the beam, dead load of the slab initially. So after that, I was assigned the respective live load for this respective building. For that, go to select your respective column, retrofitting column, select frame section, select RET, click on OK. Go to assign option, go to frame line load. Here we need to select the distributed load. So here we need to add to existing load. Here we need to calculate the value of distributed load. So for that, go to select 0.5 cross 0.5 is the new dead load for the respective column. We need to multiply this by 25. click on enter button. So it will be consisting of 6.25. so here we need to enter the value as 6.25. add to existing loads, click on ok. So it will assign the dead load. So after that we need to assign the earthquake load again go to select all building, go to assign option, go to shell area load uniform. Here we need to select earthquake load in x direction. So here we need to replace existing loads in global x direction, which is consisting of 50% of the live load, which is nothing but 1.5 times of live load. So click on ok. So after that go to select all the building again go to assign, go to shell area load uniform. Here we need to select earthquake load in y direction, global y, at replace existing loads, click on ok. So it will assign the earthquake load in y direction like this. After that we need to analyze this respective retrofitting building. So for that go to analyze option again go to check models again. Just we need to select these 3 check marks, click on ok. So after that go to analyze option again, go to run analysis again we need to check for the analysis. After that we need to compare this respective deflection value, shear value, bending moment value with general building. So after that, for that go to click on display option, click on show results option. Here we need to select the load case. Just I am selecting EQX static load. Here we need to pick story drift value. Here we need to pick building output, story shear value, click on ok option. So it will show the respective values like this. So here we need to select the values of deflection value. So select Control C option. Again we need to select this respective sheet number 3. Just we need to paste here. So after that select one more sheet 4. So after that we need to take the story shear value. Here we need to select the story shear, Control C button. So we need to paste this respective story shear value in this respective Excel sheet number 4. So this is the deflection value which is related to G+3 general building without using retrofitting. So after that select sheet number 3. So this is the deflection value which is related to the G+3 building with retrofitting process. So I will copy this respective with using retrofitting too without using retrofitting sheet. So I will initially delete this respective y. So after that I will paste the respective value here. So select sheet 3 again we need to select copy option. So after that select here, paste here. So these are the comparison for the respective deflection value. So here with using without using retrofitting, the deflection value will be consisting of 0.300406. So with using retrofitting, the value will be consisting of 0.00028. So with using retrofitting, from these respective deflection values we have observed that by using retrofitting process we can decrease the value of deflection. So after that I will compare the respective shear value. So just I will cut these respective values from here. Just I am selecting Control X button. So after that here we need to paste these respective values. So after that select sheet number 4. So select VQ VX VY. Just I will select copy C, Control C option. Select sheet number 2. Just we need to paste the respective values here. So with the help of this retrofitting value, the value of shear will be increases as compared to the respective deflection value due to presence of the extra thickness of the column. The value of shear as well as bending will be increases. So this is the concept which is related to the retrofitting process of G+3 building by using ETABS software. Thank you.